Wow, this is a huge crowd. I think that's the first time I'm giving a talk and people have to sit on the floor, and there are no more chairs available. So if you want to stand in the back, you can feel free to sit up here if you want to hear me better or need to see the screen a bit better. OK, let's get started. My name is Jan. I'm head of development at LilyDo in Frankfurt. That's a small startup. We do mainly e-commerce and logistics. And besides that, I also do freelance consulting on Symfony, Silex, which has been discontinued, sadly, Zulus and Graph, so everything that has to do with Symfony, basically. But my bragging rights about queuing systems, I earned before that in my consultancy. What we had to do basically included tasks like sending out email campaigns that had to address 40 million people at once, big data queries and analytics, shipping tracking, all that kind of stuff. So this is how I learned queuing systems, basically. Also, I have to say that, I'm legally bound to say that, we're hiring. So if after this talk you have the impression that my company does cool stuff, you might want to come up and talk to me. If after this talk you have the idea that I have no idea what I'm talking about and you know way better than we do, please come and talk to me, because then we need you even more. But let's get straight to it. Just one more thing before we start. Who is aware of this sentiment? Documentation is code. Has anyone ever heard that before? Oh, wow, I hope more people knew that. OK, so what that means is we should document our code in the same way that we code. So we should couple our documentation to our code. We should update it in sync with our code. And we should ideally version our documentation the same way that we do our code. So given that this presentation documents knowledge, this presentation is code. And the code of this presentation is basically a huge markdown file. And as such, is it also versioned on GitLab. So you can find the presentation there. You can also see all the versions of the talk I have ever given. There is a release in the repository for each conference I attended. So if you want to see how this talk evolved and you maybe want to look up some things, it's available on GitLab. And I also will upload it to Joined In later tonight or maybe sometime tomorrow. Fun fact, that's also probably the only talk in history that has commits like update dependencies, because sometimes I need to fix my Reveal.js workflow because a new version of Gulp on Node.js broke it. So why do we want to do asynchronous processing? Any ideas in the room? Maybe people already thought about that? Yeah, sure. Shout them right in.
Well, because you would like the computer to be part of some other computer to know existence. For starters, but honestly, because the operations that you need to perform is too costly to be performed in, for example, one web request.
Yeah, so offload, load, basically. Any other ideas? Just shout them right in. I'll repeat them for the camera. Don't wait for others is also nice, yes. The most obvious one is basically cut down reaction times, right? Everything that you do outside of your main thread, outside of your main process, enables you to deliver your response faster to your user. Move long-running logic is what we already heard. Also, you might want to offload some logic or some work to other systems, which is basically transfer load, as we also mentioned. And then all this buzzword bingo, right? So this enables you to do microservices, scaling, parallelization of work. You can check all these off. So if you have no kind of attack vector on how to get started with any of these, like microservices, scaling, or parallelization, introducing message queues to your architecture is a great way to get started. OK. But you should also keep in mind that introducing this to your architecture is a huge shift in paradigm. It kind of changes the way you do work. So please, before you do that, make an informed decision. Think about if you really want to do it. No. Keep in mind that just because you have a cool hammer, not every problem is a nail, right? Yeah. OK, so this is why we want to do this whole talk here. And then why do we talk about requests? Well, I always talk about requests because I'm from the Symfony world, and in Symfony, everything is a request, basically. But for our sake, for our discussion's sake, let's just assume it's just one entry point into your application. We can have many entry points, be it front-end controllers, event listeners, webhooks, CLI commands. Everything that triggers your application basically can be an entry point to asynchronous work. OK. So let's get right to it. Old school processing kind of goes like this. We have a request that hits some kind of controller, front-end controller or MVC controller. Then we trigger some business logic in our application, and then we return the response to the user. The lowest hanging fruit here, the easiest improvement we can possibly do to the architecture, is not to basically move things off the thread, but just to shuffle them around a bit. And then we have something like this. We have the request incoming. We have the controller do the basic work. We deliver the response, and then we do all the other logic that is still necessary. Now, some frameworks have this already built in as a feature. Drupal and Symfony can already do it. But has anyone ever done this before? 1, 2, 3, 4, 5 people. How did you do it? For example, yes, the Swift mailing component in Symfony uses this from the get-go. But I mean, how did they do it technically? What's the magic trick behind it? Yes?
FASTCGI SHUTDOWN.
Yes. FASTCGI finish request, basically the same. To the rescue. So what we can do in our source is basically this. We can do some fancy response code, generate the output, and then call FASTCGI finish request. What this does is it basically closes the client connection, meaning all output will be rendered useless because it won't be received by the client anymore, but we can continue execution of the script. A few things to keep in mind, though. First of all, it requires PHP-FPM, so it might not be available everywhere. There are some workarounds. Symfony has some really weird hacks to achieve this without FPM. We can maybe talk about this later. And you also have to keep in mind, this still blocks your main server, right? So given that we just continue the main thread, we do not offload any load somewhere. We just move it away from the visitor and from the request. What we also have to keep in mind is that we retain a log on the session by default. So if we just go back a slide, once we called FASTCGI finish request, even though the client connection is closed, your session might still be active, or definitely is still active. And that means that any incoming request for that same session, so basically any request incoming from the same user, has to wait until we release the session. You can do so manually. You can just call session write close, and then PHP-FPM is free to handle other requests for that same session. Also, obviously, keep in mind, it's not asynchronous. It's just faster for the user. And there are just 2 links here for the PHP and Symfony documentation on how to use this, showing you how to use the convenience wrapper that is available in Symfony. And that's also the one that's used by Drupal, because on the core, Drupal uses the Symfony component. OK. But what we really want to achieve is going, again, from this to this. So we want to be able to deliver the response faster, have the main thread end at this point, and shift the logic somewhere else, basically running in parallel somewhere else in your system. Now, how do we do this? What we need is a message broker. So they kind of all work the same. We have an application that publishes messages into our queuing system, and then we have the queuing system taking care of persistence, keeping track of messages, analytics, metadata for each message, and that kind of stuff. Then we have a consumer process that runs somewhere on your infrastructure that can, depending on the tool you use, poll or long poll, or maybe even gets pushed the messages. And then again, depending on the tool that you use, might be able to report back to your message broker once it's done consuming that message. Again, keep in mind that it's very important where you run this consuming process. I've had clients that were really proud of their message queue architecture, and they were complaining to me why it wouldn't speed up their application. And then we had a look at their architecture, and we saw that they were basically running 3 consuming threads, which is nice because you can do stuff in parallel and you move load off the web server. Only problem was that they were basically running the same jobs on the same machine than they were running their Nginx. So what happens is that you don't really shift the load somewhere else. You still run it on the same machine, and you basically gain nothing except more complicated architecture. So ideally, you would run them on a dedicated machine, or at least have them set up in a way that they have specific resources allocated to them. OK. As I said earlier, this talk is versioned. There is a version of this talk. You can find it with this tag in the repository. That's more in-depth and more tutorial kind of talk on how to set up these 3 queuing systems, so Gearman, Rescue, and RabbitMQ. But for this session here today, I decided to tackle more of a high-level, lessons learned, best practices approach. But if you're interested in how to set things up, you can find this talk and the video of this talk online. OK, so let's get to it. How do we do message queuing? We'll just quickly go through all the different queuing libraries and systems I have had the fun of dealing with so far, and we'll just briefly have a look at them and how they work, or how you queue messages. So this is PHP Rescue. It's a fairly simple queuing library. What you get here, all these examples are from Symfony, but they basically transfer to any application the same way. You define a job, which is in our case the heavy lifting job, and you add some payload to that job, and then you just queue the job object into your queue. That's basically it. The nice thing about this approach is that we don't have to take care of any form of serialization of the message. We just define the payload as an array, and the library takes care of all the rest. We have RabbitMQ, which is a bit more complicated. Again, we define the payload. We get our producer that produces the message for us. So the approach here is kind of different because RabbitMQ works different. And then we publish our message as a string. And why is this different? RabbitMQ is not queue-based, but more message-based, meaning that the RabbitMQ broker can decide on its own how to deal with your message, where to route it to, which consuming thread to forward it to. So in RabbitMQ parlance, the message is way more important than the queue, which is why we only get our producer and then publish the message to it, because everything else is basically handled with RabbitMQ. OK, next one, Bernhard. That's a fairly simple queuing library. Again, it works kind of the same way than PHP Rescue. You define your payload as an array. You have your message type, and you define the queue as part of your message instantiation, and then you just produce it, meaning publish it to the queue. Also fairly simple. PHP-ENQUEUE kind of works the same way. Again, we have to predefine the processor, meaning the thread that is responsible to handling this message, which kind of is the equivalent to the queue in this case. And then we have to pass along our payload as string in this case. And for everyone who's using Symfony, ever since Symfony 4.1, we also have a messenger component built into Symfony that can simply dispatch message objects on Symfony. As usual, takes care of basically everything and does all the serialization and deserialization for you. OK. What we've seen here is basically this, and this is the biggest takeaway from today's talk, right? They're all the same. It doesn't really matter which one you use. If you're not looking for a specific feature, they kind of work all the same. You have to define a payload, you have to define a target, and then they do the rest for you. Which means we should basically write some kind of abstraction on top of this. So instead of using the library-provided publishing service or publishing class, you should add an abstraction layer on top of this. This makes it fairly easy for you to swap out your libraries later on, because you just have to change the producing or publishing or sending part once, and your whole application will profit from the new library. It's basically the same way we work with database repositories, HTTP clients. We nowadays hardly ever use libraries directly. We try to abstract away most of their calls so that we can swap it out more easier. It's just a big important aspect of decoupling your application and make it also easier to test later on. OK, so having said that, let's look at how we consume messages. Again, we'll just go through all of these examples step by step. So we have, again, PHP Rescue. This is the same heavy lifting job class that we instantiated earlier when we first published the message. But this time, we have a look at it internally. We have to implement the interface, and the interface tells us that we need this perform function method, basically. That's the method that's being called with our payload once we're processing that message. And in that function, we can basically do whatever we want. Take note here that we just get that array directly, so you might want to add some validation or sanity checks before you start working with it. RABBITMQ, again, a bit more fancy than the rest. We get a pre-instantiated message class here, which contains the string. That's very important to know. It's the string that we handed over to RABBITMQ earlier. And it also contains some metadata, for example, message headers, timestamp, UUIDs, that kind of stuff. But again, here, we have to take care of decoding the message ourselves, probably validation. And what's different here is that we have to return something. So as we saw earlier on the architecture schematics, is that some libraries actually have a back channel, and RABBITMQ is one of them. So after we process the message, we need to tell RABBITMQ that this message has either been successfully processed or has somehow failed and needs to be requeued back to the system. OK. Bernhard, again, fairly simple, although we already get a pre-configured message object, which already contains the array we published earlier. Fairly simple, but quite comfortable to use. It's probably worth mentioning here that Bernhard is an abstraction library on top of other queuing systems. So the feature set it can provide is basically reduced to the minimum that all of its sub-libraries have in common. PHP-ENQUEUE, again, more working like RABBITMQ. We have a message object that we get. We have the string that we passed along earlier, which we can decode again. And we also have a bit of a context here, just like in RABBITMQ, although it's not part of the message object, it's passed along as a separate object. And again, we have a back channel here, which enables us to inform the message broker on how successful we were with processing that message. OK. And again, the Symfony component, fairly easy. We get the same message object already pre-instantiated that we pass along in the queue, and we can work with it right away, which is the most comfortable way of working with things. And again, they're all the same, right? That's the big takeaway. Repeat after me. They're all the same. Yeah, I know. It's hard when the realization hits you. Your choices doesn't really matter. So again, we can add some abstraction on top of it, meaning that in our message consuming class, there shouldn't be any logic. Again, it's the same thing we do in other parts of our application as well. In our controllers, in our event listeners, in our CLI commands, we don't implement logic itself. We use a DI component that we call to call logic somewhere else, and we again decouple our application. Message consumers should work in the same way. So we should receive our payload, and we should simply pass along the payload to some other service that can take care of it. Other benefits that we get from abstraction. Any basic questions so far? OK, cool. So logging and UUIDs. Introducing queuing systems to your application can make debugging hell. because you have to keep track of what kind of message was published when and where to better understand why it's crashing somewhere in your system later on. Because as this is processed asynchronously, we don't necessarily have the effect of the user, for example, uploading a file, and then we see the immediate crash. It might take anywhere from a minute or an hour or even a day till we see the actual impact of that payload. Which is why we add something like this to most of our publishing classes. We add a unique ID to each message, and that makes it easier for us to follow that message along as it passes through all the queues in the system. What you can also do is have a sort of reference table somewhere to reference each of those messages to a user in your system, which again makes it easier for you to look up information on who's responsible for that message. You can also just add stuff like that to the message itself. Something else, events. So what we can do here is we can basically dispatch an event before and after we post a message. You might want to do that in order to, for example, modify the message before you actually publish it. So what we did later on in our system, we refactored the UUID component that you just saw earlier, and we have an event listener that actually listens to every pre-published event and then attaches the UUID to the message, so we don't have to take care of that for ourselves again and again in each publisher. And again, the same with the post-publish event. You might want to publish this event to react to a certain message, probably do some things you need to do before that message can even be processed, or trigger another message that depends on that message. Again, this can make debugging a bit harder, as event dispatchers tend to do, because you distribute your logic throughout your application and you don't have it in a central place. Another important aspect to keep in mind is the dead letter exchange. Has anyone ever worked with queuing systems and a dead letter exchange? OK, cool. It's a really nice concept to have, and probably something that is worth exploring in other parts of your application as well. So imagine the following. You have a message that you publish to your queue, and that message fails for whatever reason. The payload wasn't valid, some preconditions weren't met, whatever. Database connection lost. Maybe you try to load an object that has been deleted in the meantime. Can happen. Now, some of the broker systems, as we talked about, can react to the message failing and actually requeue the message. And what will happen is that you basically start a vicious cycle. So the message will fail because preconditions haven't been met. You will requeue it, the message will come up again from your queue, it will still fail, and things can go on and on and on and on. And if you don't have a dead letter exchange, these things start to pile up, because this message will basically be in your queue forever. And then the second message will come along, and the third message, and fairly soon you'll have 10,000 messages in your queue that can never be properly executed. So what you do, is you try to keep track on how often this message has been tried to process. And then you set a certain threshold in your consumer, which again, pretty nice to have an abstraction on your consumer, because then you can set this once. And before you actually process that message, you can check on the message metadata if the number of tries has already been reached. And then you can do various things. What the basic approach of that letter exchange is that you take this message out of its respective queue right now and move it to a separate queue, which is the dead letter exchange. And you can have it there just for storage reasons, so you can debug it later on. But you don't necessarily have to do it. You can publish it to a database. You can just store it in a log file somewhere. That basically depends on your use case. You might want to just send out an email if you're sure that it won't happen that often. Hint, it probably will not. Also a great way to DDoS somebody's mail account. Yeah. So keep in mind that you need to have a way to somehow deal with messages that you cannot process. OK, graceful shutdown. given the fact that all of these consuming processes and threads are long running, you need to have a way to shut them down without losing data. If you were just to stop the thread and kill the PHP process, what would happen is that you would lose data. You can never be 100% certain that currently the process isn't processing a message, and if you kill it right now, it might not be done with that message, and that message might be gone. Losing a message is basically losing data. And you wouldn't want somebody to just randomly delete files or entries from your database. And you have to deal with your message queue the same way. You need to make sure that you never, ever lose a message. Thankfully, that problem is fairly simple to solve. After every message you consume, you just implement a check, should this thread shut down, and then you can exit gracefully. And this method can be implemented in various ways. I have worked with flags that you can set in the file system, flags that you can set somewhere in the database. We've also worked with a certain type of message that you can publish to the queue, and once that message reaches the consumer, it will flip that flag, and the next message will know that we will have to shut down. All of these have different advantages and disadvantages. For example, publishing a message basically means that you don't have precise control over when it will actually shut down, because you don't know how far along in the queue you are and how long it will take you to reach that shutdown message. Whereas having it reside on the file system basically means you can't use it for two distributed setups, because you would have to actually set that flag on every server in your infrastructure. So we have decided on using the database method. Kind of like you probably do feature flags as well, we have decided to do feature flags in database too, because it's just the easiest to edit and update. Okay. Again, any questions so far? Yes.
What about the signals from the OS to stop processes?
Yes. The question was how we should handle signals from the host OS, which is a pretty good question. What you can actually do in PHP, you can implement a signal handler. And in this case, stepping back a bit, if you implement the shutdown handler in PHP, you get a bit more time for your process to shut down. And what we try to do, we tried that approach as well, is to use that sig handler to set that flag and then just hope that the time we get from the host OS is enough to finish the current message. Fun fact, most likely it isn't, which is why we have refrained from using that again.
So the libraries didn't handle this, right?
Not all libraries do. The RABBITMQ library is fairly straightforward and can handle it, but the more simpler ones don't. Yes?
And if using that signaling but don't send a kill signal but some other signal and handle that, that might be a nice way to shut down that process without the OS.
Yes, what you can do is send custom signals, basically, and react to those custom signals. But again, depending on how your architecture is set up, you might not be able to send custom signals. So in that specific case, we used supervisor D. And at least I'm not aware of any way to teach supervisor D to send custom shutdown signals. Yeah. But it's a fair point. If you do it manually or of any kind of automated or scripted way, you could probably do it. Good point. OK, let's go on. That's actually quite a good segue into the lessons learned part. This is me pouring my heart out now from all the pains I've gone through. First and foremost, the most important one, PHP threads are not meant to be long-running, which is only a partial fault of PHP itself, but more often the fault of any libraries and dependencies that you use, because people, and in all honesty, I probably don't do it as well, people just don't care of their memory footprint in PHP, because most often we just have to handle one incoming request and then we shut down again, and so memory leaks are not often a problem, which you can see in some of the libraries out there. So that's something to keep in mind. And I think it also makes you kind of a better developer if you keep in mind your memory footprint more often, and doing more message queue work kind of forces you to do it. And as we just talked about, use supervisor to check and restart your consumer. So with supervisor D, does everyone know supervisor? Some people do. So it's a small tool that can basically check up on your processes, keep track of them, make sure that they're still running, make sure that they don't overstep their memory limit, make sure that they don't overstep their time limit. And it's a really nice way to configure a maximum lifetime of your consuming threads or a maximum memory footprint. And what you can do then is to just shut down the consumers if they take up too much memory or if they've been running for too long, kind of a preemptive strike of a memory leak, just shut them down every now and then. What you have to keep in mind, though, is that rebooting the consumer might take some time. So I've seen setups where booting a RABBITMQ consumer can take up anywhere from 30 to 90 seconds, which is quite long if you want to basically restart it every hour or so, because that means you basically lose 1 or 2 minutes every hour of working time. So that's kind of a balance you all have to strike individually depending on your setup. What you also have to keep in mind is the database connections that are needed by your consuming threads. So it's the same with, as any problem you have when scaling. The more processes you spin up, the more load there is on your database, and sometimes you might reach a limit on database connections, which can be quite painful because as your working processes tend to be rather long-living and your Apache PHP processes or PHP FPM, which also reboots every now and then, are not as long-living, you might end up in a situation that all of your consumers basically block all the connections to your database and there are no more left for your actual web server, which is pretty bad because then your customers come in and there's no more database available for them and all your other processes work just fine, where it should actually be the other way around. You can probably live without your consumers for a bit, but you probably can't live without your customers for too long. Huh. And if you can, you have a great business model. Okay. Also, better quit when inactive. So this is something we had to edit into our deployment workflow because we shut down all of our consuming processes during a deployment. We'll talk about that in a bit. But we needed a way to figure out if they were even busy or not. So what we did is we kind of built our own monitoring on top of the consuming process, meaning that every time we start processing a message, we set a flag in the database, and every time we've finished with that message, we change that flag back again. So we have a pretty nice dashboard that can tell us if all consumers are idling or not. And that dashboard also is available as a REST API or a CLI call. And what we actually added to our deployment process is a sort of like grace period. So before the actual deployment begins, we call that CLI method, CLI command, to make sure that no consumer is currently working. If any single one of them is still working, we just sleep for a bit. 10 seconds might be enough, and we try again. And we do that for a maximum of 3 or 5 minutes, I guess, in the hope that usually in that window we find a time where no consumer is active and we can continue with the deployment and shut them all down. If we reach that time threshold and we haven't found a suitable time window, you have to decide what you want to do. Do you want to force quit all your consumers because you want to go ahead with your deployment, or would you rather abort your deployment? That's probably depending on the actual content of your messages and whether you can afford the risk of losing a message or you really want to wait. Okay, more lessons learned. Basically, we've covered some of these already. Set a maximum runtime, or some of the libraries also implement a maximum of messages to process, which is the easiest way and can also be implemented on top of your processors as well. You can just keep track in a private property on how many messages you have consumed so far, and if the limit has been reached, you can just shut down that consumer. RABBITMQ, again, one of the most advanced queuing bundles libraries there are, implements something that they call a soft quota. So they keep track of their memory usage and how it increases with each message. And if they reach a point where they think that the next message might overstep the limit, they shut down before they reach the limit, which is pretty nice and makes sure that you never actually overstep on your memory limit. Also, prefetching can be fun. Some of the libraries do prefetching of messages, meaning that, for example, when your RabbitMQ worker spins up, they don't only load one message from the broker, but a certain configured amount, which by default I think is 100 messages, just so that you can consume messages faster and you minimize network I/O in between. What might happen, though, is that when you have multiple consumers running, multiple workers running, and they all prefetch a various amount of messages, you might start to process messages in a different order than they were actually published. Just something to keep in mind. And we already covered custom classes and stuff you can do with them. OK, lessons learned on the messages side of things. So try to keep your messages as short and compact as possible. You might not think that is important, but most of these queuing systems actually keep their queue in memory, even if they have some kind of persistence layer in them, like a database or file system. Most of them keep the messages in memory just for performance reasons. And that might not add up too much, but if you have, for example, the use case I mentioned earlier, a campaign where you want to send out 40 million emails at once, and you publish all these messages, and even though each of these messages might only contain a user ID, an email address, maybe a timestamp, and the name of the campaign, that's like 4 or 5 strings multiplied by 40 million times, all in memory, and you're pretty much out of memory. Which is why it might make sense to have the broker also run on a dedicated machine, just like any other database would. Again, depending on your need. You should use common formats like JSON or XML, or even Google's protobuf format if you've ever worked with that, because they're really compact and they are language and platform independent, which is something you should keep in mind, because one of the nice things with the queuing systems is that you can actually consume your messages on a totally different system in a totally different language or operating system than where you actually published it. Coming back to what we said in the very beginning, message queues enable you to connect to other subsystems. So, for example, you might have the user upload videos, and you might want to do the actual video rendering in another system. So you publish a message to the queue saying, please convert the video with this ID to that format. And you might do the actual encoding in C or in Swift or what have you. And then you need a message format that can be wrapped by these other languages. So use platform-independent messages formats and do not serialize PHP objects or arrays directly. Been there, done that, painful, takes up lots of memory, and especially serializing PHP objects might even break between deployments, because if the actual object that you might want to deserialize and serialize into changes between deployments and your queue isn't upgraded, you can run into funny errors. Okay. Message transformation, we just talked about most of this. Make sure that before you process the message after you have deserialized it back to PHP, add some kind of validation on top of it. There are tons of assertion libraries that can help you out here. Symfony's form component is also really nice to do that. Basically, you should treat a message that comes in from your queue like any message and payload you would basically accept via a public API. Never trust your message queue the same way you would trust your user, even though in this case you're probably the user, but you should always mistrust yourself. And also reload all the entities that are involved. Don't try to have them completely serialized and deserialized in the queue, because the actual state of the entity might have changed in the database in the meantime. Keep in mind that when you have huge message queues, the point in time between publishing and consuming the message might actually be hours or even days sometimes. So you cannot be sure that the object hasn't changed in between, so just reload them to make sure. Message header. Some libraries enable you to add additional information to each message. And you can do that to add all the kind of metadata we talked about before, so UUID for messages, for better debugging, timestamps, session IDs, user IDs, maybe even app IDs. If you have a setup where you have multiple applications publishing into the same queue, it might be interesting and important to know which application actually put that message in your queue. So that's something you should put in your message header as well. And also, if you have a message format that is bound to change, you should also version your message format and put the version add the version as part of the message information. Basically, again, the same way you would treat a public API. If your API formats change, you might want to release a version 2 of that API. Or you would need people that post to your API to add which version they're currently posting and which posting format they're adhering to right now. Okay, deployments. Okay, when we do a deployment, we need to redeploy our working threads as well. As they run from the same code base or might run from the same code base than your application, it's important to restart them as well, because as long as one process is running, I'm sure you all know, once the PHP thread is started, all the files are kept in memory and you are not aware of any file system changes in the meantime, so you have to actually restart the process. Which is why we need the graceful shutdown we talked about earlier, and the possibility to only shut workers down when they're idling. Again, if you use something like supervisor D, it's fairly simple, because you can just call supervisor and tell them to shut down all the threads, and then have your deploy process wait for a few seconds for that to complete. And then you can just continue with your deployment as usual, and then you can again call supervisor and tell them to restart all the consumers again. Supervisor is fairly easy to configure. And ideally, you can have this configuration as part of your code, have it make it part of your repository, and every time you update your installation and your deployment, you can also update the configuration of supervisor. So with every deployment and restart of supervisor, the configuration is also updated as well, which makes it fairly easy to, for example, upscale the amount of workers within a deployment. You can just update your configuration file, redeploy, and then you have more workers deployed or have them deployed in a different configuration. Okay, other challenges. As mentioned earlier, this is a significant change in your infrastructure, not only from a technical point of view, but from a approach point of view. So it kind of changes the way you have to think about certain features, so make sure you're aware of that. Again, choose your libraries and dependencies carefully. Don't start out with the most potential, powerful, complex solution there is. Start small. Build a clean abstraction layer on top of it, and you can update your library easily and go and have your library swap out for bigger, better ones on a need-by-need basis. Also, please keep in mind again, moving load is not removing load. Even though if you ideally remove it from your web server, you still have to do it somewhere else. So you're not actually saving huge amounts of cache there. You still have to process that somewhere. You might be able to process it faster on machines that are better equipped to handle this. For example, again, the video example, you have the user upload a video, and you might want to process that video on a server that has a dedicated GPU, for example. which makes the process itself faster, but also more expensive because you need dedicated hardware for that. Also, rethinking is necessary of some features. For example, you have the user upload an image and you want to generate a thumbnail. Before using message queues, you could have shown the user the thumbnail right after he or she uploaded it, because you generated that thumbnail as part of the upload request. Now, that might not be possible because you cannot guarantee when that message to actually generate the thumbnail has been processed. So you might need to show the user some intermediary state, have a possibility to notify the user once your job is done. And that brings you in a whole new territory of work and pain if you have to start to work with WebSockets and pushing versus pulling. And yeah, that can be fun too. Good thing is that for most of us PHP folks, we're out of the bigger picture there because that's more of on the JavaScript and stateful development kind of side. Then another important aspect, we already touched on that, is the interdependency of messages. Please, please, please try to set up your application in a way that makes the order of messages obsolete. You should never ever assume that your messages are processed in the same order that you publish them, because not all queuing libraries can guarantee it. And even if they try to guarantee it, they might fail and have to requeue that message, and then the principle is broken. So the safest method here is just to kind of have a robust and defensive architecture that can handle that. And keep in mind performance, especially for everyone that's using Doctrine. Who's using Doctrine here? OK, everyone. Doctrine is not made for long-running processes. Yes, you can flush and clear the unit of work. You should do so between messages. That is something you can add to your abstraction layer on top. But again, Doctrine is not made for that. When I gave this talk the first time and Marco was sitting somewhere in the audience, he's like, yeah, use something else. OK. Let me just forward this to all of you. Use something else. OK. Now, before we end this talk, just a short reminder, personally from me. Feedback is important. All of you probably joined in, and the feedback you can give to your presenters there. I know that ultimately we're responsible for the quality of our talks, but to improve our talks, we need the feedback from all of you. And you should probably think of reviews like issues, right? You don't want your people to write non-helpful issues or bug tracks as well. I've had joined in reviews that were like, great talk, 3 out of 5 stars. I was like, yeah, thank you, but that's not particularly helpful. So if you have something that you think can be improved, please, please, please mention it in a way that I can actually act upon it. And also, if there's something you like, please mention it directly and explicitly so that we know what we have to keep in our talk and what actually works maybe for the next talk as well. Yeah, so again, thank you very much. If you have positive reviews, I would be happy to entertain them on Joined In. If you have negative reviews, please use Twitter. And that's all from my part. Thank you so much. We do have 10 more minutes for questions, right? Yeah. Cool. Or not. Oh, we have one.
Yeah, sure. Can everybody hear me?
Yeah, it's just recording. There's no audio system.
Okay. So what are you using out of these systems that you've shown? Are you using a RABBITMQ or using something else?
So the last big application I was working on with queues used RABBITMQ, though I would personally say that is way too much of an architectural impact and way too much configuration for small use cases. And as this is the question I get most, I have prepared a little something for you.
RABBITMQ and then
well, that
nothing
depends.
else.
Again, RabbitMQ probably way too overpowered for your use case if you get started out initially. Again, depending on your use case, but I would say that in 90% of the use cases, you can make do with a smaller, more compact tool, which is why I recommend Bernard or PHP-ENQUEue nowadays, which is what we also use. So we just started introducing queuing systems to two smaller applications, and we use Bernard on top, for that.
Yeah. Okay. And word of warning: when you're speaking about supervisor, if you have like more than 300 of these workers per instance,
yeah,
it starts acting weird. Like dropping the instance, dropping the workers, not reporting it. It's a bug. It's a known bug. Like it's not reproducible easily, but it's there.
Yeah. So what I would advise to do in general is use that 300 workers per instance, right? Did I get that correct?
700?
Okay, so what we try to do in most of our setups is to have a smaller number of workers per instance and have more instances instead, because that's just an approach that for us was easier to scale. There's a question back there.
I want to ask you, what is your approach to deal when your message queue is overloaded? For example, it's full and you cannot publish more messages inside it. How do you deal with it?
Yes, I've only ever had that problem once. So for anybody who can hear it, the question was how to deal with a situation where your queue actually runs full. In our custom publisher, we handle that case. So if we are not able to publish a message, two things might happen. We might not be able to publish a message to a certain queue, in which case it would be forwarded to the dead letter exchange directly so that we don't lose it. And if we cannot publish the message anywhere, we write it out to a custom log file, which we can later on reparse to republish that message. That's a valid edge case, though. You should be prepared for that. Okay. Cool. Thank you very much. Enjoy your coffee break.